Adam and not Adam, Jack and Noah. I actually missed a couple of the problems because I forgot to record the class. So we are working on the homework. We just did numbers. I can't move my board. Here we go. We just did numbers 5 and 6. They're summation problems, so I'm not going to go back and do that, but that's what we did. You can freeze the frame and look at how I did it. And here's the other one. You can stop the video and stare at it. Okay. Sam, did you think this was confusing, the summation? Let's do another summation. I don't think there are any more in this lesson, but let's just move on to, let's look at another lesson for a summation problem. That might be a helpful little thing to do right now. So hold on. All right, a new summation problem. I'm going to the next lesson. Let's do this one. We're going to sum j equals 5 to 6. This one's actually easier. 2 over j. So what that means is we're going to put a 5 in for j and then a 6 in for j because it only goes from 5 to 6. So this is going to equal 2 over 5 plus 2 over 6. And then you would find the common denominator for that and add them together. This is lesson 35, number 8. And if you added those guys together, you would get 11 over 15. And that's how you do a summation problem. That one was a little simplistic. Let's just look at one more. So we get n equals 0 and to 3. So we get 3 to the n over n plus 1. So we're going to put a 0 in. We're going to do 0, 1, 2, and 3 because that sums up all the numbers from 0 to 3. So we get 3 to the 0 over 0 plus 1 plus 3 to the 1 over 1 plus 1 plus 3 squared. We're just substituting in for n. Now we're putting the 2 in for n. 2 plus 1 plus 3 cubed over 3 plus 1. Do you guys get this now? Does that make sense? And the answer to this one is going to end up being, just for your future reference, it's going to end up, I can't find this problem. This is lesson 35, number 9. It'd be faster if I just did the problem instead of looking up the answer. It's going to be 49 over 4. All right, so that's how you do summation problems. Okay, back to our problems, our regularly scheduled problems. Let's see, we did 5 and 6, and now we're moving on to 13 and 14. So let's just get a new board for that. All right, 13. All right, this one is evaluate, do not use a calculator. Yikes. Okay, so this is A. This one has 3 parts, just to top it all off. Okay, pay attention to this. This is hard. Arctan of 1. So when they're saying arc of anything, it means you're going to find the angles whose sides are 1. Always make it as a fraction. If we're talking tangent, we're talking opposite over adjacent. We build ourselves a cute little triangle. Let's just do it on the axes just to make it more official. So we make ourselves a set of axes like this. The opposite and adjacent are both going to be 1. So this is going to be 1. This is going to be 1. And so what angle would that be? Does anyone want to guess what angle would live in here? What would theta be? Anybody? I need to know you're out there. My other class I do this with, they all have microphones and they all talk to me. It's great. Okay, good. Sam, 45 degrees, because this would be the square root of 2, right? And you're saying what angle. So whenever you see arc anything, you're saying what angle has these 2 sides, and you build yourself a little triangle. So let's try the next one. They do get harder, like this one, of course. So we get tangent of arc sine of 3 over 5. The first one was definitely the easiest one. Okay, so this one is find the angle. This one is not find the angle. So let's just build ourselves. If we have arc sine, it's going to be opposite over hypotenuse, right? So here we go. We're going to build our little triangle thing. I like white drawing on this board much better, even though I still didn't do a good line. So here we go. Let's see. Opposite is going to be 3. Hypotenuse is going to be 5. You have to find the other side of this. Here's theta. Now these two sides, 3 and 5, are not our friends. Like our friends are the 1 square root of 2, and the 1 square root of 2, 3. 1, 2 square root of 3. These guys are not our friends, but we can still use them. What we're going to do is we're going to use these two sides to find the third side. You use the Pythagorean theorem, or you should know that this is a 3, 4, 5 triangle, so you don't have to use it at all. So you build your sides, and now this we don't need. We did that. We would just say this is equal to theta. So now we go back and we say, what's the tangent of theta? Well, the tangent of theta would be opposite over adjacent, so your answer would be 3 over 4. And that's your answer right there, 3 over 4. So first you use these two sides to find a third side, and then you just find whatever it says out of here off of the sides of the triangle. Okay, let's just try another one, see what happens. Of course it's going to be harder. All right, here we go. What is it? Cosine of the arctan of -3. Okay, this is similar to part B. So this is going to be -3 over 1, and we know that tangent is opposite over adjacent. So let's just build our little triangle thing. We have a -3 for our opposites, so it's going to be down here like this. Actually, I have to tell you something that's in the book that I didn't tell you yet. It's so weird because it doesn't feel like anybody's here. It feels like I'm totally talking to myself. Tangent, now you could get a lot of different angles. We could have also drawn the tangent over here like this, because this would be -3 here and this would be -3 here. Well, when you're trying to find arctans, there's special angles. So let me just show you the special angles. Tangent is always going to be in between, this is in between these two. So tangent is always going to live between -90 degrees and 90 degrees. Sine is always going to live between -90 degrees and 90 degrees. Cosine, however, is going to live between 0 and 180 degrees. I think these are all going to be equal to 180 degrees. So when you're finding an arctan of a tangent, it's always going to be in these two quadrants. So we'll be doing more of these. Just keep this in mind. Store this in your brain, some compartment somewhere. All right, so this is opposites -3, adjacent is 1. We have to find the hypotenuse, so you have to use the Pythagorean theorem. 1 squared plus -3 is the same as 3 squared when we squared it, equals c squared. So we're going to get 1 plus 9 is c squared, so c is going to be equal to the square root of 10. So hopefully I did all that right. This is number, I'm just going to check as I go. Number 13, yep, square root of 10. So this side's going to be the square root of 10. So now this is just theta, which is going to be right here. So now we're going to do the cosine of theta. Cosine is opposite, so it's -3 over the square root of 10. And then of course we have to rationalize that because we're really good rationalizers. And we get -3 square root of 10 over 10. So how do you guys feel about those problems? I need some feeling markers. You can use the emojis too. They are fun. They're okay. Come on, more feelings. All right. Amy just says she doesn't like them. Ah, nice. Sam's really into these. All right. I'm not hearing anything from Adam or Rosie. These guys are fast on the emojis. Okay, Adam, Rosie, are you there? The emoji button is down right underneath Sam's post there. It's a smiley face. You just hit the smiley face and you'll get some options. Yep. Okay, let's leave these guys and we'll come back to them. I'm sure they'll be friends of ours for a long time. They'll be in every lesson until we're done with the book probably. So eventually you'll get them. All right, what else do we have here? We have 13 ups, right on to 14. Okay, symmetry. Nice. All right, 14. It says determine whether the graph of each equation is symmetric around the x-axis, the y-axis, and the origin. Okay, the first guy, we have our axes. These are easy too. Put these up with your explanation point ones and your now our summation problems. They're not hard. So you get a shape. Let's see if I can draw a shape. There we go. I drew a shape. All right, let's try to get it balanced here. All right, they want to know whether this is symmetric around the x-axis, the y-axis, or the origin. So if you folded this guy in half across the y-axis, would it look the same on the other side? Yeah, it would. It would look the same. So it's symmetric around the y-axis. So first part you would say y-axis. All right, is it symmetric around the x-axis? So if I divided it in half around the x-axis, would it look okay? Would it match up equally? Not that it looks okay. So we're going to get x-axis. Yes, it's symmetric around the x-axis. Now the origin is a little bit trickier. The origin, you can't really fold it across the origin. So you have to do a little test. If you replace the x and y with a negative x and y and it still works, let me write the, they give you the formula. 9x squared plus y squared equals 9. If I replaced it with a negative x and I replaced the y with a negative y, if it ends up being the same thing, then it's symmetric around the origin. Is the figure drawn to scale? Of course it is. Doesn't really matter. So we're going to get 9x squared plus y squared equals 9. Since it's the same as this when you replace the x's and y's, then it's symmetric about the origin. Okay, that's one little thing to tell. Let's go to the next one. We have this little doohickey thing. Okay, so we got this. It's so much easier to draw on this board than the whiteboard. It's not even funny. Okay. I should just have, like, on the table, I could just write and it could go right up to the whiteboard. That would be so much better. Okay, so this one looks something like this. All right, you have to tell whether it's symmetric with the x-axis, the y-axis, and the origin. You know the origin is 0, 0 right here. So here we go. Let's write down the equation for this. It's y equals x cubed. All right. So if you folded it in half across the y-axis, would it look the same? No, it wouldn't look the same. So it would be no for this one. If you folded it in half along the x-axis, would it look the same? No. They wouldn't overlap, so it's a no. Let's do our replacement test. If I put in a negative y and a negative x and I cube it, is it going to be the same? Whoops, I meant to put in a negative y. So if I put in a negative y and a negative x and I cube it, we're going to get negative y equals negative x cubed, and divide both sides by negative, you get y equals x cubed. So they do work out to be the same, so it's a yes. And that's how you do that. Does that make sense to you guys? Anybody? Okay, so it's easy to see if it's symmetric around the x or y axis. There is a test you can do by substituting in negative values, but it's easy enough to see. But the origin sometimes isn't hard to see if it's symmetric. So that's why we do this little test where we put in the negative values. All right, next one. Whoops. All right, let's go back here. We have our 14s. Only one more, 17. Well, let's see what that is. And then we'll check to see if you guys have any other problems. 17, oh, brother. I have to do this thing. I guess you guys had to do it, so I will do it. Remember this? We haven't done these in a long time. Minus 2 at negative 140 degrees. All right, write your answer in polar form. Nice. Okay, let's see. Maybe this will be the day everyone gets it. You can just, I'll record this on YouTube. I'll put it up on YouTube, and you can just watch it over and over and over again for your viewing pleasure. Okay, here we go, y and x. So we're going to plot the points. It's negative. I do not have a calculator. My daughter stole it, and I have no calculating abilities right now, so I'm going to just rely on the book. So we're going to go around negative 135 degrees. It's going to end up being here in this quadrant, right? But it's a negative 3, so it's going to be dotted. So we just have to determine this angle is going to be 45. Correct? All right, but we're not going to use this angle because we have our negative number here, so we're going to shoot it through like that. Vertical angles make this a 45. And now this is going to be a positive 3. We create our triangle like such. And then we have to find y and x. So to get x, we say x equals 3 cosine of 45 degrees. And to get y, we say y equals 3 sine of 45 degrees. Remember, x always goes with cosine, y always goes with sine. And then we put this in our calculator and out pops a number, 2.12. Now these are approximate values, and I haven't taught you very well, but you should use these approximate symbols. So let's do approximate symbols. And this one is going to be the same thing because sine and cosine of 45 are the same. So it's going to be 2.12. All right, let's do the other one. Wasn't too bad, was it? So here we go. All right, this is the same thing. Yeah, Amy, what's that mean? E-H, eh. Like, I don't really get that kind of eh. Your smiley faces can really help me know what to do. Like that, if I did that. That's kind of, I'm very confused. Let's see. This could mean, ew. I don't know what that could be. There's all kinds of, there's not a lot, but hey, use them to your advantage. Okay, so let's do this one. This is negative 140 degrees, so it's going to come around here somewhere. It's going to be dotted as well because it's a negative 2, but let me just see something here. Yeah, it's going to be a negative 2, so it's going to be dotted as well. So we're going to do plus a negative 2. It's kind of a little bit confusing, but we're going to do plus a negative 2 at negative 140. So this is going to be 40 degrees right here. We're going to pop this back up here, and this is going to be 40, and this is going to be positive 2. So here we go. We're going to do, we'll call this y and x again. So we're going to say x equals 2 cosine of 40 degrees, and y equals 2 sine of 40 degrees. All you have to do is memorize this algorithm, kind of. If you do x, you do cosine, y is sine, multiply it, this is the length of the vector, put it in your calculator, and you get 1.53, and this one's going to be 1.28. We'll do 29, we'll round it. Now we're just going to add our x's together, and we're going to add our y's together. So we're going to add this plus this equals this plus this. And so we're going to get, if we add our x's together, we're going to get 3.65 I hat plus, all these numbers are positive because they're in the first quadrant. So we're going to get plus 3.41 j hat. They want us to put this back into polar coordinates. Any happy faces or anything like that? Anything? Any thoughts? Alrighty. Whoops, I missed my little top. Okay. This is it, and then we'll go on to geometry unless you have anything else. Okay, we're going to plot the point. So we're going to go 3. We'll just put it out here. This is the point, 3.65 at 3 in 3.41. Okay, so yeah, I like the emojis. I think they're really kind of cute. They're cuter than I think the normal ones, actually. Okay, so I plotted this point. This is the coordinate of the point. That means the x value is 3.65 and the y value is 3.41. You have to use the Pythagorean theorem on this guy, which is really torturesome, 3.41, but we have calculators. At least you guys have calculators. All right, equals c squared. Yeah, I feel like we do need more emojis. Maybe you guys could write into the WizIQ people and tell them that they need to add more. So we are going to get, believe it or not, that comes out to be, when you take the square root of this, c comes out to be 5. Don't ask me how that works, but that's what they have in the book. So the resultant right here is going to be 5. Now you have to find theta. So you say the tangent of theta is opposite, which is 3.41 over adjacent, 3.65. And then you say theta equals the inverse tangent of theta, inverse tangent of 3.141 and 3.65 is approximately equal to, put that all in your calculator, and we get 43 degrees. So our answer is 5 at 43 degrees. There you go. For some reason I'm not seeing all your writings. Okay, there we go. All right, that's how you do that. That's an awfully long problem, but it wasn't too bad. Okay, is there any more in the lesson? Lesson 34? All right, anybody else? You didn't ask that many questions, really. Is that because you're getting better at them? Could that be? Hopefully. I think you guys have learned a lot this year. This is difficult. When I was looking at your last test, I haven't gotten them yet, but as I was looking at how hard the problems are, it seems like you can do some pretty complicated things. Wait, why do I owe you a soda? Who are you talking about? Oh, okay, because you jinxed. I'm not reading as fast as you guys are. Okay, let's switch to geometry mode. Hopefully in this one, I think my house is going to get busy here. We are switching to geometry mode. So let's go to, believe it or not, we're on chapter 14, area and volume. And that sounds pretty easy, doesn't it? Chapter 14, area and volume. That sounds like we can handle this, right? But considering that we're not doing A through D geometry, that we're doing E through Z, this is going to be harder than your normal area and volume. Sorry, there's like chaos in my house. All right, you guys around? Okay, here we go. I'm just going to run through formulas. Here we go. Area equals of a rectangle. Does everybody know the area of a rectangle? Okay. Really? You're kidding. Your dog? Wow. Don't you have headphones on? All right. Well, it doesn't matter if your microphone's on. You don't even need headphones if you don't have that on. Okay. So area of a rectangle. Everybody together. It's length times width. That was like first grade or something like that. Okay. Or sometimes they call it base times height, however you want to call it. Okay, we're good. Everyone good? Okay, let's do area of a square. Okay, it's side squared. If you don't like that, you could do base times height. It's the same thing because squares are rectangles. Okay, everyone good so far? I think we're doing really well today. Yeah, we need a lot of encouragement in this class. Okay, how about the area of a parallelogram? Did you ever think of that? Area of a parallelogram. Anyone want to give a try for that? Area of a parallelogram? Let me just make this one a little bigger. Okay. Wait, I probably have a shape for a parallelogram. Then I wouldn't have to draw it. Let me see. Wow, they're really lame on the shape. Oh, nope. Okay, here we go. Look, I can draw really nice now. Okay, so here's the parallelogram. So this is the height of a parallelogram, right here. Okay, so that is our height. This is our base. So the area of a parallelogram is base times height. Huh, see, easy. Okay, that's 3 for 3, not too bad. Okay, area of a trapezoid. Here we go, area. Let's see if my little shape drawer has a trapezoid. Okay, it does. Check this out. Okay, area of a trapezoid. I'm going to teach all my classes like this. I can do so much better. Okay, this one is area equals 1/2 base 1 plus base 2 times the height. We've done that before too. So if you have a trapezoid like that, that one looks like a regular one. So let's draw this line down here. All right, so this would be base 1, base 2, and this would be the height. The reason it works like that, it's kind of like two triangles that you added together. So if you don't even remember the formula, just think if you draw a line kind of like this, you're dividing it into two triangles. So it's going to be base 1/2 base times height times 1/2 base times height. And that's that. Okay, so memorize these formulas. There's no getting around that. Here's one you guys know and love. Area of a, here we go, area of a triangle. Does everyone know this one? It's 1/2, what? Yes, base times height. Or you could always do base times height over 2, like that. Yep, okay, look at that, 5 easy formulas. Now, the thing when you go to do the homework problems for these, sometimes they're going to give you the area and you have to find the base or the height. Other times they're going to give you the base and height and you have to find the area. So you have to play around with them a little bit and look at the examples. So today we're just going to go through the formulas, make sure you know them. Okay, we have the trapezoid. Let's do an example because these problems are actually a little bit harder, of course, because we're doing E through Z geometry. A little bit harder than you might think. So let's go down. I'm going to do an example from your book. We're going to find the area of an isosceles triangle. Okay, here we go. Yeah, all right. So let me draw it since I have my beautiful drawing tools. Here's an example. Here's our trapezoid. And they are telling us that the bases are 8 and 20. So I guess this one would be 8, and this one's 20. And they tell us that the base angle has a measure of 45. I feel like I'm doing SAT problems right now. You are supposed to find the area of the trapezoid. So Let's see. We know the area of a trapezoid, the formula is area equals 1/2 base 1 plus base 2 times the height. So what part are we missing here? Anybody see a part that we're missing? Just checking to see if you're with me. Yes, we're missing the height. So we're going to draw on a line like that. And I'm going to make that a right angle because we drew it in there. Now, this is a 45, 45, 90 triangle. So how can we find the height? I told you this was E through Z geometry. Don't let that title fool you. Okay, so we know if the top is 8 and the bottom is 20, we have to figure out how long this is. So I'm just going to draw a dotted line down here. We're going to think this through together. So this is going to be 8. And so it's going to be 20 minus 8, which would give us 12. And then we're going to divide that by 2, and we're going to get, it's going to be 6. So this is going to be 6. We don't really care about this side, so this is going to be 6. They did tell you that it was an isosceles trapezoid, so that means that these are going to be the same, and the base angles are going to be the same. That's important. You can't do it for any trapezoid, but this is isosceles trapezoid. Now, what would the height be? Does anyone remember their formulas? So this one's really easy. You don't really need a formula too much. Yeah, 6, because it's opposite, sides opposite, equal angles are equal. And now we have all that we need to do the problem. So it's going to be 1/2 base 1 plus base 2 would be 28 times 6. So we're going to get 14 times 6, and we're going to get, it's going to be 84 square units. If they don't give you the units, you just put U squared. Okay, sometimes you might need to know the 30, 60, 90 triangle thing. Okay, we're starting to venture into formulas you don't know. Formulas you don't know. Now, I know you probably think you know every formula, but here's one. If you have an isosceles or an equilateral triangle, that means that all the sides are equal. We can find the area of that guy just by knowing one of the sides. Now there's ways to get around this. So if you know, let me just give you the formula. So the area of a isosceles or an equilateral triangle, all the sides are the same. Okay, area of that is going to equal side squared divided by 4 times the square root of 3. Yep, that's how you do it. So if we have an example, they're giving us an equilateral triangle where the perimeter is equal to 24. So what would each side be? All right, it's the same answer as last time. Each side would be 8, right? So we get 8. So if you want to find the area of this guy, you can just put it into this formula up here. So you're going to say 8 squared over 4 times the square root of 3. 64 divided by 4 is going to be 16 square root of 3 units squared. You can either memorize this formula, which is one you don't know, or I'm going to show you the other way to do this problem. We can drop a perpendicular line down from the vertex here. Let me just get a better one. All right, check this out. Okay, I dropped that. I didn't drop it the whole way. Darn. Okay. Let's drop this guy down right there. Still didn't drop it the whole way. Okay, we made a right angle. If it's equilateral, every angle is going to be 60 degrees, right? 60. And this guy is going to be 60 divided by 2 is 30 degrees. Did you guys see that? Because this would have been 60, but it's equilateral, so the perpendicular bisector, it would divide it in half. So this would be 4 right here. And we could use our 30, 60, 90 triangle. Remember the side opposite the 60 degrees is the side opposite the 30 times the square root of 3. So we could find the height of the triangle using our 30, 60, 90 triangle thing. This is how I'd probably do it. I probably wouldn't memorize this formula, but it is a handy dandy formula in case you can't find the sides. But just remember this is just a good thing for SAT review here. So if this is 60 and this is 30 and this is x, this is going to be 2 times x, and this is going to be x times the square root of 3. So the side opposite the 60 is the side opposite the 30 times the square root of 3. All right, and then we could do the problem. Area equals 1/2. The base of that whole triangle would be 8 times the height is 4 square root of 3. And so you would get the same answer, 16 square root of 3 units squared. Okay, hopefully you got that, because we have more formulas you don't know. I know, can you believe it? All right, let's just put another one down here. We're going to find the area of a rhombus. Area of a rhombus. Rhombus. I'll just write that. So the area of a rhombus, does everyone remember what a rhombus looks like? Let's see if I can draw a rhombus in my special shape department. Here we go. Area of a rhombus. It's kind of like a square, only it's more tilty. Okay, or it can be a square. All right, so the area of a rhombus is 1/2 diagonal 1 times diagonal 2. I would just recommend you memorize that one. So let's see if we can draw this in. Let's do this shape here. There's our rhombus. Let's just make it all bigger. All right, so it's just going to be, the area is going to be, you have this diagonal times this diagonal times 1/2. So it would just be diagonal 1 times diagonal 2 times 1/2. So just memorize that. The problems are pretty straightforward with that guy. Okay, we will not go past 12:30. I'm going to work on doing that. If two triangles are similar, then the ratio of their area. Now this is something that we have to talk about here. All right, I'm just going to type this out. I have typing abilities as well, which I don't have to handwrite things as soon as I find it. Okay. All right. Hold on a sec. Line color white. Okay. There's a theorem. It's 14.7. And it says if two triangles are similar, then the ratio of their areas is equal to the square of the ratio of the lengths of any pair of corresponding sides. Okay, hopefully you guys can read that. I don't know how that types up there. Okay, so the ratio of the areas. So this is how it looks like. If you have area of triangle 1, the ratio of area of triangle 1 over the ratio of area of triangle 2, it's going to equal the ratio of the side 1 over side 2 squared. All right. So a problem might say the ratio of similitude of two triangles is 2 to 3. So we have two triangles, their ratio of their two sides is 2 to 3. I'm going to start going fast here to try to get this all in. If the area of the smaller triangle, so we have two triangles, The area of the smaller triangle is 12 units. What is the area of the larger triangle? All right, so the area of triangle 1 over triangle 2. So we're going to call this one x. So the area of triangle 1 would be 12 over the area of triangle 2. Okay, the area of triangle 2, we don't know, is equal to the side, so it's going to be 2 over 3 squared. So that's what this means. If two triangles are similar, the ratio of their areas is equal to the square of the ratio of the lengths of any corresponding sides. So that's something you also have to memorize. So they're giving you the area of the smaller, just make sure you keep the smaller number on top. And so then we just do a quick algebra problem, equals 4 over 9, cross multiply, and you get x equals 27. All right, keep that in mind. Anyone else want to say anything? And the last thing that we have to cover is area of a regular polygon. And we're kind of pushing it. We're not going to get everything in today. So I might just do a video for the rest of it just to help you out. So let's just do real quick, since we have 4 minutes, let's do the area of a regular polygon. So let's see if I can find a polygon. That would be really cool. Ah, found a polygon. This is awesome. Whoa, I could never draw a polygon like that in real life. Okay, so here we go. If you have a polygon, and I have a center of the polygon, it's kind of a center, there's some things we have to keep in mind. The central angles of regular polygons are congruent. So if I drew angles down from the center to each of the vertex like this, I'm only going to do one triangle. If I do triangles for all these angles are going to be congruent the whole way around. All right, keep that in mind. The measure of all the angles is going to be 360. So if I wanted to find this specific angle right here, what I would do is I'd take 360 divided by how many sides there are. There's 1, 2, 3, 4, 5. So we divide it by the number 5, number of sides, like that, and we would get, what would we get, Adam? I don't have a calculator, remember. So it would go in, 72. Thank you. Boy, you got it before I even thought about it. So it would be 72 degrees would be this angle. If you're going to find the area of any polygon, if we have a length of sides, so say the side is 5, what we're going to do is we're going to pop out this little triangle. So let's just pop this triangle out right over here. Oh my goodness, I'm going to teach all my classes this way. Okay, this is 5, and we get this angle right here is 72. Well, we can figure out, if we can figure out the area of one of these triangles, and we know that there's going to be 1, 2, 3, 4, 5 additional triangles. We find the area of the one triangle, and then we take it times 5. Well, there's going to be 5 altogether. 1, 2, 3, 4, 5. So what we do is we have to get a hypotenuse, and so these triangles are all going to be equilateral because it's a regular triangle. So this is going to be 5. This is going to be 36 degrees right here in the degree. So we can take, this is going to be 2.5. So we use the Pythagorean theorem, which I'm not going to have time to finish this. You use the Pythagorean theorem to get this. And then we're just going to take the base, which would be 5, times the height, which is the Pythagorean theorem of this and this, would go here, times 1/2, because it's a triangle. And then we're just going to take all that times 5. And that would give you the area of the whole pentagon that I made. I can't make heptagons or octagons. All I can do in this is pentagons. So, all right, well, that's basically it. I'm going to do a video for you for the rest of it because there's still more information, and I still have to put your homework on the syllabus. So there we go. Math in 1 hour. That's what you get. All right. Okay. We'll see you guys on Friday. Bye-bye.